Okay, so my name is John. I work in Waterloo office on Chrome on the ecosystem infrastructure team. And today I'm going to be talking about web platform tests. And namely, I'm going to be talking about how you can automate tests that you previously could not with a tool that we are writing called testdriver. So the goal of this presentation is to give you some context into web platform tests, why you should use it, maybe some background info. Then we're going to talk about the different types of testing that you can do and go more in depth into testdriver, how you can write testdriver tests, and how we can have feedback and talk about and prioritize which things we want to figure out how to automate next. So first, what is WPT? WPT is Web Platform Tests. How many of you have heard of Web Platform Tests before? Okay, keep your hand up if you've run a Web Platform Test before. And then keep your hand up if you've written a Web Platform Test before. Okay, that's good. That's like roughly half the people in this room. But Web Platform Tests is a shared test suite among browsers that tests the web platform. It's used by most major browsers, and we have support from all of them. The main goal behind this is to reduce interop issues and have the web platform be easier and more predictable for web developers to use. We have a series of tools that we're working on and monitoring, and we have dashboard that you can see live results. So this is a screenshot of the current dashboard where we're working on doing things like updating these per commit and having updates every hour. We're also working on having live results from pull requests so that you can see in real time what changes to this test suite your changes are doing before they land. So there's a number of different types of tests that you can do with web platform tests. There's first, there's just normal JavaScript tests, so that are run through a JavaScript harness that has assertions and sets up the environment and does everything. So an example of such a test is this. This is something that Mike West wrote that I just got from the repo. Does a bunch of URL assertions and doesn't do anything too fancy in terms of functionality, and it's fairly straightforward. The second is ref tests, which is very popular, for example, with CSS, and it involves rendering two web pages, and one is the one that you're trying to test, and the other one is a reference. And you compare screenshots, and you're looking for a specific type of behavior and how it's rendered. So in this sense, here's an example of one where we're looking at gradients and in CSS properties. And this is the web page that would be under test. And this one is the reference that we're comparing it to. If you can't test what you're trying to do in either of those categories, say you want to test animations, for example, that don't exactly have an obvious analogy there. Until recently, the only thing you could do was have it manual. And nobody really likes manual tests. There are a number of reasons for this. They're very expensive to run because they take developer hours, they take human hours. A real person has to sit behind the desk and go type in WPT serve and try and figure out exactly what behavior they're looking for. Even though most of the developers are very talented, it does leave room for human error as well. Furthermore, you can't include them into CI, so they can't be run in your normal suites. Regressions will be missed, and usually they'll just be out of date and they're hard to maintain, and they're just not all that good. So one possible solution here is using what this talk is about, testdriver, which is a tool that is built off of it's based on the Webdriver API. So for anyone who's familiar with that, basically trying to be like a real user using the web browser. So things like clicks, navigating, and window resizing, and everything that you could think of. And to use this in web platform tests, all you need to do is include these two scripts. One is the default implementation, the other is if there's a vendor-specific override of certain behaviors. So it now allows us to do things like trusted clicks. Before, you could only perform untrusted clicks in web platform tests. But now, for example, all we need to do is just include that, and you have the test driver object, and you can click buttons, click anything that would let you start new behavior and that control flow in that way. Another example is sending key events that's recently. So now you can send input to elements. So things like text boxes. Other popular requests that we got were things like tabbing to change focus. And all of these are possible now with this. In the future, we have plans to have things like sensors. So things like, we've been talking to some people at Intel about this, and I'll go over in a minute the sort of roadmap of how we're going to work to get this into testdriver. Things like permission, so get user media, get geolocation. Things like sending pointer actions, so touch events and pointer down, pointer up, and all of those events. And window management, like switching to windows, getting window rect and setting window rect, minimizing and maximizing. So if you are a team and you're working on a spec and you want to test something in web platform tests, but you don't see any way to do it, these are the steps that you would follow to have a path forward to having that in testdriver and continuing to do it. So one of the first things that it needs to be is cross-browser. So we need to have an implementation that's going to work not just in Chrome, not just in Firefox, but in every major browser that we want to, so we can successfully gauge interop and all of that. So the solution here is to write a specification, and to whatever spec you're working on, you write a WebDriver extension. The documentation for doing this is in the WebDriver spec. An example of where this would be right now is in the permissions specification. They have an automation section on setting and getting permissions through WebDriver. So the next problem is now it needs to be implemented in a WebDriver implementation. So the standard way there is either send a patch to whatever WebDriver, like whether it's Chrome driver or Gecko driver, or talk to the owners and figure out priorities and see who can get if it can be implemented in a certain time. And then after those two steps are done, then we can implement it in testdriver. And for this, it's kind of the same dance. There'll be lots of documentation and tutorials on this, so hopefully it'll be easy. But a little more on that last step, just kind of a high-level overview of how you would do that. To use testdriver, you have to run web platform tests in an automated way. So there's kind of two ways to run web platform tests, and that's using WPT serve or WPT run. WPT serve is where you start up the web platform test server and you navigate to the URL of the test that you want and manually run it. WPT run is much more automated and uses WPT runner, and you just need to specify in the command line what file and what test you want to run. And to use testdriver, you need to do it in the WPT run way. And here's an architecture diagram that is a bit out of the scope of this talk of how WPT runner works. And for testdriver, we need to modify the protocol and executor in this piece right here. So sort of the high-level overview of how it will work is we modify the testdriver object itself and add whatever API you're using. Then we modify the executor and the protocol base classes. And then we get into browser-specific implementations. So whatever vendor you're doing things for, if the first two steps are worked out, the rest of the work can kind of be delegated between whoever owns that certain part or that browser. So for the first part, as an example for send keys, it's just a matter of defining a JavaScript function, and that will pretty self-explanatory. It does the error checking, and we'll send it off to an internal command in an internal class. For the next part, updating the base classes for the protocol and the executor. All browsers will use this part, and we just write our abstractions so that we can be cross-browser and everyone can use the same API. And then finally, the browser-specific parts are up to the specific executors and protocols that those browser uses. So for example, in Chrome, right now we're using by default Selenium to do this. So this is kind of a piece of the highest level in the stack of where it would be called. In the future, we have plans to change Chrome to mostly use the Webdriver protocol directly, which would remove the roadblock of having to submit a patch to Selenium to have your Webdriver feature be used. But that will be coming soon. And as another example, for Firefox, they use a marionette executor, so it does the same thing. And the key point here is that we need to make sure that we maintain that each vendor can kind of have their own code path and their own features that they use to run these, but we have the same API exposed over top. And so this leaves us at this is still new, and we're still developing the new things that we should automate, so we can automate existing manual tests and provide new features for people who want to improve their coverage in their specs on web platform tests. So to get feedback for that, there's a few places you can look. You can talk to Public Test Infra, which is a mailing list on W3C. You can do the mailing list of the ecosystem infrastructure team, or send me an email or DM me, and we'll have a conversation about how we might be able to get some of this in testdriver and talk to the right people. And there's time for questions if anyone has any. Yes.
What's the Java browser support yet?
So the question was, is it just Chrome or does this work in other browsers? And for the current, for everything that works right now, it's in both Chrome and Firefox. You can test on both.
So I have like a couple questions. One is, like when you said that you can add a WebDriver extension, so what exactly is the process in terms of, like how do I perform what's the form to do that?
Yep. So the WebDriver extension would go not in the WebDriver spec, but in the spec of whatever it is. So for example, if it's permissions, it would be in a separate section in the permissions spec, and it would be labeled as a WebDriver extension and have the exact steps to do. And WebDriver would sort of be like a transport layer that does that. And I guess in terms of, to try and answer your question more specifically, the logistics of it would be submit a patch to whatever spec you are editing, and then add a WebDriver person as a reviewer to go through and work out any details.
Okay, the second question I had was, in terms of the future plans, you have like
Yep.
Can you talk about particular?
Yep. So window management right now, there's plans for maximize, minimize, getting the rect of the window and setting the rect of the window. And I think those can be expected, at least in Chrome and Firefox, in the next quarter. Because those are commands that are already part of the WebDriver specification, and it's just the last step that needs to be done.
So my question concerning the last step, what is the task in Chrome itself that we're using? Are we using the DevTools protocol, or are you using?
What do you mean by the last step in Chrome itself?
So what is how does Chrome receive commands from like Selenium, WebDriver directly, and
So with Chrome driver specifically, most of the heavy lifting for Chrome driver is done with the DevTools protocol. Yeah. Yep. That's actually a really good question. We haven't really explored using testdriver in reference tests yet, but I like this idea. And I think that, yeah. I'm glad you brought that up, actually. Yeah, I think in the future that should be possible, but in terms of infrastructure, we haven't looked into how it would look in ref tests and not as like sort of a wrapper on test harness tests. So as long as that is not too much of an issue, I think that should be good. Yes.
I'm partly just about input that like direction, like the keyboard, like when I try to like write a use case, right? I find it hard like exactly what inputs are already supported by Webdriver. I don't know. Like, do you have a dashboard or anything that these kind of things supported? Like, I can look for examples and start writing from that.
Oh, for WebDriver and which implementations support which things? Yeah. So in the WebDriver specification, at the top, there's a link to vendor-specific reports that will, so each vendor, it will link to a page that should be updated that has their progress on that. But that's just manually done by the vendors themselves, and there isn't any sort of standardized dashboard. I guess the best thing there would be, if you're really worried about something being supported, you can see who made the dashboard and you can reach out to them. For Chrome, it would be me. Yes. The question was, is it possible to call Mojo.js without implementing the Webdriver? Oh, you're asking to implement Webdriver, do we need to implement DevTools? For which browser? Yep. Yeah, so currently, yeah. I'm not too familiar on the specifics of Mojo. Maybe if I understand your question correctly, to use this, you can do, I was talking in an earlier slide about sort of the protocol and executor layer. And there, as long as the commands are consistent with the rest of the browsers, which currently are based on the Webdriver API, we'd be able to call and sort of transport into the browser in any sort of black box way, as long as the behavior is still the same. So if Mojo can do that, I guess that would be that would work. Yeah.
So I think that the question was highlighting something important. Creating features in the browser that doesn't which is what is the process for adding something new to Webdriver API and getting that tools. Say, add the some example that referring to is Intel is working on a new generic web.
Yep.
It's exposed to uses not covered by Webdriver.
Yeah, there isn't any.
Configuring mock sensor values. Say like vendor phone is flying at this velocity or whatever. And so today that's implemented by using an internal API flag that allows JavaScript to intercept the calls from Blink into the browser process. And by intercepting those calls, you can inject whatever data that normally the browser would take. And so the question is, like, what is the process for getting those kinds of data injection APIs added all the way to the stack so we can get a test to the Webdriver API and actually talk.
Yeah. So for Chrome specifically, I think we'd need to go. I'll separate your question sort of into two parts, or at least my answer. One is setting up the fields so that we allow other browsers to copy the behavior, and two is like capturing that behavior and implementing it in Chrome and Chrome Driver. So the first step, which is writing the WebDriver spec extension, is specifically to solve that problem of setting the stage so that other browsers can be interoperable. But once that happens and we do have some sort of specification, at least in Chrome Driver, the easiest way would probably be adding some sort of DevTools routine, some sort of thing on the protocol, and then using WebDriver as sort of like a transport and the way to do the interop in the spec that then calls that and does the responses there. So I guess it would, involve having the easiest way I can think of off the top of my head, write a subroutine in the protocol and use Chrome Driver to call that. Yep.
So if I write the layout test, have web platform,
Yeah.
can't you use testdriver?
Yeah, so that's the, I'm like 90% sure on this. That's the second script that is included, the testdriver vendor. So in layout tests, it would be using that. And then that would just be run in layout tests. And if it's run anywhere else, and then the importer and exporter would do that. And when it's run somewhere else, it would use the testdriver script. So yeah, in layout tests, it would be run by a testdriver vendor. Cool. Thanks for coming, everyone. And feel free to talk to me if you have any more questions.